Right, so today in this video we're going to talk about converting between polar and rectangular coordinates and equations. Let's get started. All right, so we're going to say polar right here and rectangular because that's what we're going back and forth between, and we'll just review what each of those are. Polar uses a coordinate system like this. So if you have this point there, it's going to have a distance from the center that we call r, and then it's going to have a rotation around from the positive x-axis that we are going to call theta. So the coordinates in a polar system are given as r, comma, theta. The rectangular system is the one we're familiar with. The same point right there. Instead of with a rotation and a distance from the center, this one we would give with simply an x distance and a y distance, right? And that would give us our coordinates x, comma, y. So let's do some conversions now. Let's say we want to convert from rectangular to polar. So let's just say, to make something up that doesn't work out super easy. I mean, it's not hard, but let's say our x and y is let's make it that a rough visual representation. We'll just call it 2, 1. Small numbers, easy. And we want to convert that to this coordinate system, right? So what do we know? This is going to be a right triangle, right? With 2 in that direction and 1 in that direction. And what we want to find out is this and this angle. So if you've done trig at all, that should start to look good to you. How are we going to find r? Well, that's just the Pythagorean theorem, right? A squared plus b squared equals c squared. Only in our case, it's going to be x squared plus y squared equals r squared, right? You see that? X squared plus y squared equals r squared. So then we're going to put in our x and a y. So that's going to be 2 squared plus y is 1. So that's going to be 1 squared equals r squared. 2 squared is 4. 1 squared is 1. Equals r squared, so 5 equals r squared. How do we get rid of that square? Well, the square root of a square is just itself. So we're going to do the square root of r squared equals the square root of 5. And so we're going to end up with the square root of 5 because we can't do anything with that. But the square root of a square is just itself. So there's the r for that. That's part 1. And now we need to find theta, the angle. And so if you know all 3 sides, you could use any trig function you want, right? You can use sine, cosine, or tangent. So I'm going to write so, ka, toa. And I encourage you to write this on every thing you ever do that requires trig. It's just easier to have one less thing to keep track of. It's easier than you might think to accidentally grab sine when you mean cosine or whatever. So little helps like that. When I was in engineering school at UCI, students all over the place were writing this on the top of their tests because it's one less thing to think about. All right, so I've got radical 5, square root of 5 for my r, but I've got 1 and 2 for my x and y. So I'm going to use the 1 and 2. So that means I'm going to have to use the tangent function because I want the tangent of this angle is the opposite over the adjacent, right? So the tangent of the angle equals the opposite over the adjacent, right? That's what TOA means. So the opposite is going to be, there's the angle. The opposite is the y coordinate, only because that's the angle we're looking at. The opposite would be the x coordinate if we were trying to get that angle right. But we're trying to get this angle. So the opposite is 1, and the adjacent one, that's the leg adjacent to the angle, is 2. So that's pretty nice. So tangent of theta equals 0.5. So that's pretty good. Now we got to use this little button from your calculator, the inverse tangent. And if you use that, you can put in what the tangent is, the number that the tangent is, and it will give you the angle. And in this case, it turns out that 26.6 degrees is the angle here. So if we're converting 2, 1 to polar coordinates, we would say that the answer to this question is going to be square root of 5, 26.6 degrees. And that's the actual converted value right there. This thing here, that could be in degrees, or it could be in radians. Whichever is working for you. Usually it's whatever setup comes from the problem. So let's convert the other way. We've done rectangular coordinates to polar coordinates. Now we'll convert polar coordinates to rectangular coordinates. Let's just pick something else here. So I'm going to say the polar coordinate is 6, and then we'll do radians just for fun. Pi over 3 radians. If you see a pi there, that's a dead giveaway that it's radians. I mean, really, what you're looking for is this degree symbol, right? That tells you that's degrees, not radians, because you could have 26.6 radians. But if you see a pi there, that's really a big clue, because, you know, radians use pi, right? So we want to convert this r, theta. We want to convert that to an x and a y. So the first thing you're going to want to do, which is always a good thing to do, is just sort of sketch it out. It's just rough, right? You're doing the actual math. You're not using a protractor and stuff, so it doesn't have to be exact. You just want a rough sketch of things. So it's going to be 6, so we'll just call that 6. And then it's going to be pi over 3. The rotation from the positive x-axis up that way is going to be pi over 3. So where is pi over 3 in the rotation? That's the question. And the answer is in the unit circle, right? So if you don't remember the unit circle, it's a good time to review. So there's 2 pi radians in a circle, in the circumference of a circle. Circumference equals 2 pi r, right? You remember that? So 180 degrees is the same thing as pi radians, right? So 90 degrees, that's pi over 2 radians. Now we got pi over 3, which means we're going to need to divide this in sixths. And if you remember, on the unit circle, when we're working with the triangles, there's only 2 triangles on there. It's either 30, 60, 90 or 45, 45, 90. And so we with the unit circle, we can divide the plane here, the polar plane, into we just think of the top half, because that's pi. So we can divide it into sixths, and we can divide it into fourths or quarters. So since that's pi over 3, we're going to divide it into sixths. So this is going to be what? That's going to be 3 pi over 6, right? And then we know we're going to have this one. That's going to be pi over 6. And then the one right here is going to be 2 pi over 6, which equals the thing that we want right there, which equals pi over 3, right? So this is our triangle. So what do we already know? What do we already know right here? What's theta? What is theta for this angle? Well, we know that when we're on sixths, they're 30, 60, 90 triangles, right? So if this is that, right, we're going to call that length 6, because that's what the r is. But we're working with theta right now. So a 30, this is a 30, 60, 90. And this is a 30, 60, 90 when it comes up the other way. So that has to be a 60-degree angle. So we know that theta equals 60 degrees. You don't have to do that, because you could just work in radians. But we also know that theta equals 60 degrees, right? Okay, so what we've got, basically, we end up, let's transpose that to where we can see what we're doing. We've got a triangle. It's going to be a little bit steeper angle, like that, probably, something like that. So the r, the distance, and that's like from the center, right? So that's like the coordinate plane, like that, right? So this length is going to be 6 right there. Let's see if I can keep my paper pretty straight here with the camera. That's going to be 6, and this angle is going to be 60 degrees. Now we can get pretty quickly where we want to go, right? We've got our SOHCAHTOA. We've got our x and our y. Sine equals opposite over hypotenuse. So the sine of 60 equals the opposite, that's y, over the hypotenuse, that's 6, that's the r that we're already given. So 6 sine of 60 equals y. So what is 6 times the sine of 60, right? The sine of 60 sine times 6. So that y is going to equal 5.2, roughly 5.2. And then the cosine, did I do that wrong? No. So then the cosine is the adjacent over the hypotenuse, right? So the cosine of 60 is going to be this leg right there. That's the adjacent one, the one touching the angle, equals x over the hypotenuse that we already know. So 6 cosine 60 equals x. So 60 cosine times 6 equals 3. 3 equals x. So now our final converted form, that's 3, and that is 5.2. On the rectangular or Cartesian coordinate, whatever, there's a bunch of names for it. And let's just see if that passes this sort of smell test. 3, 5.2, 3, because this is a rough sketch. It's not exact, right? But proportionally, it's going to be close. That's 3, that's 5.2. That seems about right. That seems about right. So good. So that's part 1. And I have been doing this for 12 minutes, and I'm going to stop and start another video for converting the equations.